Hey there and welcome. Ever had that feeling where you know your stuff inside and out, but you're still not getting full marks in an exam? Yeah, you're not alone. Today, we are going to crack the code on how to get every single point on those tricky questions.
It's the big question, right? How do you walk out of that exam hall knowing you've bagged every possible mark? You could be an expert on alkanes, but just knowing the content? That's only step one. The real secret is knowing exactly what the person marking your paper is looking for.
And this is your secret weapon, the official mark scheme. Honestly, think of it as the examiner's playbook. It literally tells you what answers get the marks, the key words they're searching for, and even other ways you could have phrased it. This is the key to a perfect score. So, to show you exactly what I mean, we're going to do a deep dive into one single question from an AQA GCSE Chemistry paper. We're looking at question 02, which is all about alkanes. We're going to break it down part by part, looking at the question and then at the exact wording from the mark scheme.
Okay, first up, we've got a table. It's showing the boiling points for a bunch of different alkanes. The first task? Plot this data on a graph. Sounds simple enough, right? But as you're about to see, the marks are hiding in the little details.
And check this out. Notice the precision they're asking for. The mark scheme gives you 2 marks if you plot all 5 points correctly, but they give you a little wiggle room, a tolerance of plus or minus half a small square. So that tells you right away a sharp pencil and a steady hand are absolutely crucial. They'll even give you 1 mark for getting just 3 or 4 points right.
Okay, so once you've plotted your graph, you've actually got to use it. Question 02.2 wants you to predict the boiling point for that mystery X, the alkane with 7 carbons. This is where your beautiful line of best fit comes into play. So, what does the mark scheme say is the right answer? And this is a perfect example of how examiners think. The ideal answer, probably from a computer-generated curve, is 98 degrees Celsius. But they know we're human. They know your plotting and your curve might be slightly different. So look at that. They give you a really generous range, all the way from 92 to 104. As long as your prediction falls in that window, you get the mark.
All right, let's move on from the graph itself. The next couple of questions are designed to test if you can apply your chemistry knowledge to the data we've just been working with.
Now, this is a great question. It's testing if you understand the limits of the graph you just drew. It asks why your graph isn't suitable for showing an alkane with only 3 carbons. Well, if you look at the trend in the table, the boiling point drops as the carbon atoms decrease. So, what do you think happens when you go below 4 carbons?
And the answer in the mark scheme is just so simple. The boiling point is lower than 0 degrees Celsius. Your graph's y-axis probably started at 0, so you physically can't plot a negative number on it. They'll even accept the graph cannot show negative temperatures. It's a simple, logical point that gets you the mark.
Next up, a question that connects the data table directly to what you know about states of matter. Using that table, what's the state of the 4-carbon alkane at 20 degrees Celsius? You know, roughly room temperature.
The answer? Just one word: gas. The logic is dead simple. The table says the boiling point of the 4-carbon alkane is 0 degrees. Since 20 degrees is obviously way above 0, that substance is already boiled. It's a gas. And look, the mark scheme even lets you use the state symbol, G. Easy.
Okay, this next one is a classic recall question. They're asking you to finish the chemical formula for nonane. They give you the C9 part, so all you have to do is remember the general formula for alkanes to figure out how many hydrogens there are.
And yep, the mark scheme confirms the answer is C9H20. This all comes from that general formula for alkanes, CnH2n plus 2. So if n is 9, then 2n plus 2 is just 2 times 9, which is 18, plus 2, which equals 20. Simple as that. One easy mark.
All right, on to the final part of the question. This is a 2-mark explanation, and this is where understanding the mark scheme is so valuable, because you have to structure your answer in a very specific way.
The question asks you to explain why nonane, that's the biggest alkane in our table, condenses lower down in a fractionating column. The trick here is to connect the properties of nonane to what's happening inside the column. And you have to remember that column has a temperature gradient. It's super hot at the bottom and gets cooler as you go up.
So how do you grab both of those marks? Well, the mark scheme breaks it down into 2 crystal clear steps. First, you have to state the cause. Nonane has a higher boiling point. That's mark number 1. Second, you state the effect. Because of that, it condenses where the column is hotter, which is lowered out. That's your second mark. Cause and effect, boom.
And here is another little gem, a brilliant insight into how examiners think. The mark scheme says they allow converse for the other alkanes. What does that mean?
It means you could have answered the question from the opposite angle. You could have explained why the smaller alkanes condense higher up the column because they have lower boiling points. It's a completely valid alternative route to the exact same correct answer.
Okay, let's pull all this together. We've just completely dissected one exam question. But what does it really tell us about what the examiners are testing? I'll tell you what, it's a lot more than just, do you know what an alkane is?
Just look at the range of skills they packed into this one question. You had to plot data with real precision, you had to interpret and predict from your graph, you had to understand the limits of that graph, apply your knowledge of states of matter, recall a key formula, and build a logical two-part explanation. It just goes to show how all these skills are totally interconnected.
So, if there's one thing you take away from this, let it be this. Knowing the science is only half the battle. You absolutely have to know how to answer. So next time you're revising, don't just read the textbook. Grab a past paper, get the mark scheme, and start cracking the code. You've totally got this.